Welcome student. I am Mr. Abhijit Bambre, working as assistant professor at Gokhale Education Society's Arts, Commerce and Science College Jawhar. Welcome you again. In chemistry paper 1, unit 2nd, that is atomic structure, in that we are started the historical representation of atomic structure. In that we are discussed in last lecture or in last video we are discussed Dalton theories, then Rutherford atomic model. What is Rutherford atomic model? Then drawbacks of Rutherford atomic model. Today we are going to start new theories, that is Bohr's theory. Let's discuss history of the atom. Niels Bohr. He studied under Rutherford at the Victoria University in Manchester. Sir Neil Bohr studied under the Rutherford at the Victoria University in Manchester in 1930. He is Danish scientist. Actually, Bohr refined Rutherford idea by adding that the electron were in orbit rather like planet orbiting the sun. Actually, Rutherford says electron in orbit are like planet around the sun, but Bohr refined Rutherford idea by adding that the electron were in orbit rather like planet orbiting the sun, with each orbit only able to contain a set number of electrons. Niels Bohr is a Danish scientist. In 1930 came forward with his a brilliant theory of atomic structure on the concept of a quantum mechanics to ensure stability of the atom. Niels Bohr is a Danish scientist. In 1930 came forward with his brilliant theories or his brilliant ideas of a atomic structure on the concept of quantum mechanics to ensure stability of atom. Bohr made extensive use of quantum theories. Bohr theory is based on some postulate that we will discuss today. Next move. It is an structure or multi-electron atoms. There is orbitals in structure around the nucleus. Bohr's theories depend on some postulate, that is electron in an atom are revolving around the nucleus in a certain permitted or fixed orbit associated with a definite amount of energy. Such orbit are called as stationary orbit. Electron, suppose here is some electron. Electron is an atom, is a structure of, suppose is a structure of atom. Consider is a structure of atom. Electron, there is some electron are revolving means rotating around the nucleus. Here is nucleus. The electron is an atom are revolving around the nucleus in a certain permitted or fixed circular orbit. Suppose L is as an orbit. Here is some electron are around rolling around a permitted or fixed circular orbit with a definite amount of energy. Such orbit are called as stationary orbit. What is stationary orbit? An electron in an atom, suppose is an example of some atomic structure. In that here is nucleus, there is orbit, some orbit. In orbit there is some electron is revolving around a nucleus. means rotating around a nucleus in a certain permitted or fixed circular orbit associated with a definite amount of energy. Here, electron is revolving in a certain amount of distance in a fixed circular orbit with a definite amount of energy, means there is no change of energy. Such a orbit are called as stationary orbit. Then the energy of electron in the orbit remain constant. The energy of electron, suppose in center there is a nucleus. Around the nucleus there is some electron. They are revolving in fixed or certain permitted orbit and with a definite amount of energy, and such a orbit are called as stationary orbit. Got it? Then the energy of an electron in its orbit remain constant. Such a state of constant energy are also called as stationary state. Next, each stationary state corresponds to a certain energy level. Each stationary state corresponds to a certain energy level. Electron in this state through are revolving around the nucleus do not radiate the energy, means they do not nucleus in atom structure. There is nucleus is an fix. Around the nucleus there is electron. They are revolving around the electron revolving around the nucleus with a energy, fixed energy, and that fixed energy state are called as stationary state. Each stationary state correspond to a certain energy level. Electron in this state through are revolving the nucleus do not radiate the energy. They do not radiate the energy. This postulate account for the fact that the electron do not collapse into the nucleus. Got it? What is Bohr theory say? There is in atomic structure there is fixed nucleus. Around the nucleus there is some electron. They are travel, they are rotate, they are revolving around the nucleus with a fixed permitted circular orbit associated with a definite or fixed amount of energy. Such a orbit are called as stationary orbit. Then the energy of an electron in its orbit remain constant. Such a state of constant energy are called as stationary state. Each stationary state correspond to a certain energy level, means different stationary state having different energies. Electron in this state through are revolving around the nucleus do not radiate the energy. This postulate account for the fact that the electron do not collapse into the nucleus. Next, the angular momentum of an electron in a stationary state or a orbit is an integral multiple of h upon 2 pi, that is mvr is equal to nh divided by 2 pi. The angular momentum of electron. Angular momentum is a vector quantity that is measure of the rotational movement of a rotatory body or a system. Angular momentum means a rotation around. It is an vector quantity. Here h divided by 2 pi, that is m dot v dot r is equal to nh divided by 2 pi, where m is mass of electron, v is velocity of angular momentum. Actually or stationary state of orbit is calculated by this formula. where m is mass of electron, v is velocity of electron, small r is the distance from the nucleus to electron. Actually, then n is principal quantum number or an integral characteristic of the orbit, or it's the number of orbit to which electron is belong, and small h is an flying constant. In other words, only those orbit or energy state are permitted for the motion of electron in which the angular momentum of an electron, that is mvr, is equal to nh upon 2 pi. Actually, it is an angular momentum of an electron in an stationary state or orbit is an integral multiple of pi h upon 2 pi, that is m dot v dot r is equal to nh divided by 2 pi, where m is mass of electron, v is velocity of electron, r is distance from the nucleus, n is principal quantum number or an integral characteristic the orbit, or is the number of orbit to which the electron is belong, and h where is flying constant. Next, when an electron move one orbit to another orbit, when electron is electron is move one orbit to another orbit, it either emit or absorb energy in fixed amount. When electron move one orbit to another orbit, when electron is moved from one orbit to another orbit, it either emit or absorb energy in a fixed amount, or that fixed amount is called as quanta. Electron is moved from one orbit to another orbit, it either emit or absorb energy in a fixed amount, or it's called as quanta. The energy change, that is delta E, is an electron jump, is given by a Planck equation, that is delta E is equal to E2 minus E1 or HV, where E2 and E1 are the energies of an electron when in the first and second energy state. E2 is second energy state, whereas E1 is first energy state. He is the flying constant and his frequency of radiation absorbed or emitted. Actually, E1 is and E1 and E2 is an energy level for an electron to remain in its orbit. The electrostatic attraction between the electron and nucleus, which tend to pull the electron toward the nucleus, must be equal to centrifugal force, which tend to throw the electron out of its orbit. Actually, electron to remain in its orbit means steady state of an electron or stationary state of an electron is due to electrostatic attraction between electron and nucleus, is due to electrostatic attraction between electron and nucleus, which tend to pull the electron toward the nucleus, must be equal to centrifugal force, which tend to throw the electron out of its orbit. Suppose in structure there is in center there is nucleus, and second orbit there is one electron. Electron to remain in its orbit is due to electrostatic attraction between the electron and nucleus, which tend to pull the electron toward the nucleus, must be equal to the centrifugal force, which tend throw the electron out of its orbit. Hence, electron is and remain in its orbit. Next, the value of delta E is fixed for a given transition. An electron will absorb or emit the energy of only this magnitude in the form of radiation of a frequency r when it undergoes a transition between the electron, that is n1 and n2 energy level. Means transition take place into n1 and n2. n1 and n2 are the energy level, n1 being energy level and n2 higher energy level. When electron absorb energy in the form of radiation, it get excited. When electron n1 and n2 are energy level, n1 is an starting energy level whereas n2 is an higher energy level. When electron absorb energy in the form of radiation, it get excited and transition take place from n1 to n2. Actually, when electron absorb energy in the form of radiation, it get excited and transition take place from n1 to n2. The energy absorbed is given by delta E is equal to E2 minus E1. E2 is an higher energy level whereas E1 is an starting energy level. Excitation is a temporary state. Actually, excitation is a temporary state and excitation is due to the excitation is due to when electron is absorb energy in the form of radiation, it get excited and transition take place from n1 to n2, means lower energy level to higher energy level. And energy absorption is given by the equation, that is delta E is equal to E2 minus E1. Excitation is a temporary state. Hence, when electron comes back to n1, that is lower energy level, it emit extra energy in the form of radiation. Excitation is an temporary state. Hence, when electron comes back to the n1, that is lower energy level, is emit extra energy in the form of radiation. The energy release is given by delta E. The equation is given by delta E is equal to E2 minus E1 is equal to E2 minus E1. See the Bohr model of an atom. Excitation state is an temporary state, right? Hence, when electron come back to the n1, here is see the energy level that is shown in figure, that is n is equal to 1, n is equal to 2, n is equal to 3, still the n is equal to 5. There is orbit, there is one orbit, here is nucleus, there is one orbit, second orbit, third orbit and fifth orbit or fourth orbit. Energy absorption, light emission, relaxation take place and excitation take place. When energy is absorbed, excitation is take place, where light emission, when here is nucleus is an structure of atom, here is nucleus, around the nucleus there is electron, they are revolving around a certain orbit or permitted orbit with a fixed radii. When energy is absorbed, electron get excited. When energy is absorbed, electron get excited and they goes to next energy level. And you know excitation is temporary state. So light emission take place, they emit the energy and they back to the ground state. Bohr atomic model the Bohr model of the atom. Here is nucleus. N1 and N2 still N5 are the energies level. N1 is an lower energy level while N2 is an higher energy level. When according to Bohr postulate or according to Bohr theories, electrons are revolving around the nucleus in a certain permitted or fixed circular orbit associated with a definite amount of energy. Such a orbit are called as stationary orbit, right? When electron absorb energy, they get excited and they goes into second energy level, that is N2. N1 is first electron are in N1 energy level, that is first energy level. When they absorb energy, they get excited and goes into N2 energy level, that is higher energy level. When actually excitation is a temporary state. So when electron come back, that is lower energy level, they emit the energy, and they come back to the same position. Got it? Bohr's model of the atom, that is N1 energy level, N2 energy level. When a electron is excited due to absorption of energy, and then the excitation is a temporary state, hence electron come back to its original position. Thank you. We will stop here.